Hello, physics class, it's Mr. Ng. Let's go over some free fall practice problems. Okay, so this problem says that during a tornado in 2008 in the Peachtree Plaza Westin Hotel in downtown Atlanta, a piece of glass dropped 215 meters. How long, meaning it wants the time, will it take for that piece of glass to hit the ground? So it feels like we don't have a lot of information, but we do. Let's go through VVATX. VVATX. Our V initial, our V final, and our displacement, right? Let's do little equal signs. So we know that the initial velocity of that piece of glass was 0. It was just hanging out still on the top of the building. And what else do we know? We know the displacement is going to be 215 meters. That's true. We want to know the time, but there's one more thing that we know. We know the acceleration of gravity. Usually I would write this thing as a negative, but because we're dealing with time, we don't really need to worry about direction. So I'm just going to go with the absolute value, which is 9.8 meters a second squared. And we're not going to use our final velocity, so sometimes I just like to cross it out. So now that we have our variables set up, you need to memorize or remember our old equation. This is our constant velocity and displacement equation. We're going to use the equation delta x is equal to v initial times t plus 1/2 at squared. This is one of the equations we've been using quite a bit, so you should have memorized it by now. And notice, because v initial is 0, we could just cross that sucker out. That guy's gone. That means delta x is equal to 1/2 at squared. And to solve for t, if I'm going to solve for t, I'm going to flip this around and I'm going to rewrite it a little bit. I'm going to divide this by 1/2 a, divide u by 1/2 a. So that means 2 delta x over a is equal to t squared. So to do the inverse operation of t squared, I'm going to square root it, right? And once I square root it, I have a derived equation. It might be good to memorize this one just because you're going to use it quite a bit. And that is t is equal to square root of 2 delta x, this is a delta, divided by a. In this case, a is going to be the acceleration of gravity. So now all I got to do is plug in, right? T is equal to the square root, the whole thing, of 2 times 215 meters divided by 9.8 meters a second squared. If you plug that sucker into the calculator, you would have found that t is equal to the square root of 43.88. So that means seconds squared. That means t is equal to around 6.62 seconds. Awesome. One down. What about the other one? Ignoring air resistance, what will the final velocity be? Oh, well, all of a sudden, we need to find this sucker, right? But we could fill some stuff out. All of a sudden, from this last problem, we figured out the time. We might be able to use this, right? We know the time is now 6.62 seconds, and now we want to know the final velocity. So here, our equation, if you remember, is v final is equal to v initial plus acceleration times time, right? Again, v initial is 0. So that means v final is equal to the acceleration, which is 9.8 meters a second squared, times time. And our time, we just figured it out, is 6.62 seconds. So our v final is going to be 64.9 meters a second. Ta-da. Right, so what did I do? I took the problem and I first identified the variables. The second part is probably the trickiest part if you don't know it. I had to remember my equations. I had to recognize that this equation was 1/2 at squared and that the other one was the equation for final velocity. And then it's just plug and chug. All right, thank you very much for watching.